All right, ladies and gentlemen, good afternoon. Good afternoon, good afternoon. Let's take a look here at what is going on. Okay, we're going to talk certainly about linear correlation today. However, let's go to my website. Website is a bit slow, right? Do you guys having slow internet today? What do you guys notice? Isn't it pretty bad today? Because my other classes have said it was not so good. Okay, let's see. Where are we at? Come on, website. Okay, there we go. Now we're at 227. Here's your schedule. So let's go over this so you guys know. Today is Tuesday, December 5th. I'm sorry, it's the 7th today. Next week will be December 12th. Your final exam is from 2:30 to what? 4:30 p.m., not a.m. That's p.m., okay? December 12th. So that's going to be p.m. What is due? And I also have to remind you guys, what is due? Assignment is due. Yes, test 4 and homework 5. So test 4 is due. It is here. You upload it in Canvas as a single PDF file. Single meaning one. There's already 2 people who have done it. Okay, and you also have homework 5. And you say, what's that going to be on? Edit linear correlation regression. I'm going to edit this for you guys here now. Let's change the date. July, August, September, October, November, December 12th, 2:30. Okay, all right. So let's go back and talk about what we were talking about. And I apologize for the interruption. Let's finish this off. This is pretty quick and simple. We already did a significant portion of it. And I guess this is going to be a little bit of time here. So let me go back again, show you the notes, linear correlation and regression. Let's get it here. Okay. Let's make sure our TI is up and running. So let's go over a little bit of these details here that we started to go over last time, okay? Yes, there is something called rho. Rho, this is a Greek letter rho here. Now, rho, ladies and gentlemen, represents the population linear correlation coefficient. R is the sample. That's just the R variable. Is your sample linear correlation coefficient. And what we're going to do is we're going to test. It's going to be a hypothesis test about whether there's a linear relationship between 2 variables, x and y. So we started to see that last time. Now, there's going to be a formal portion of it that's a hypothesis test to let you guys know. I'll start off here. That you're going to test whether or not there's a linear correlation. Now, The test here is this. This is always your setup. Either rho is 0 or rho is not equal to 0. Rho is 0 corresponds to no linear correlation, linear relationship between variables. So either there is no linear correlation between variables, or there is a what? Linear what? Correlation. Either there is a linear correlation or there's none. Okay? Now here's really what the requirements are. So let's go over the legal requirements for this process, right? You have bivariate data, and the sample pair data has to come from a what? Random sample. That's no big deal. It's always been random. And then we first have to perform what's called a scatter plot, okay? That's when you plot the variable values, the XY variable values. That's plotting that we seen last time, right? Didn't we see the scatter plots last time? We talked a little bit about that. Yep, you're going to plot those two variables, X and Y. And I'll show you how to do that on the TI. So you can do it on the TI. And then we want to see if there's a straight line pattern, okay? If the data values can be on a straight line. That's the idea. And then number 3, we want to look out for outliers, okay? Because there are outliers. This test is very sensitive to outliers. And they must be what? Removed. These are the known errors. And at times we may calculate the linear correlation coefficient with or without other known outliers when considered a linear correlation. Formally, we require both variables x and y to have a normal distribution, which is known as bivariate normal. This is difficult to check, so we rely on 2 and 3. So yeah, I mean, generally you want the variables to be, I should say, what, normal? And as they say, it's hard to check, so we rely on the 2 and 3. Okay, so we remove the outliers when they exist, and we do a visualization of the scatter plot. Hopefully it's in that of a line. So to remind you guys of the scatter plot, we talked about that last time, didn't we? You guys remember? Did they show you guys how to do that on the TI? If not, we'll see it today. So you're kind of trying to see whether your data is on a what? Straight line pattern. That's the scatter plot. And here's kind of that line they're talking about, L. And so hopefully you see something like that. That's the idea. And if there is, if you have that, you can proceed to your hypothesis test, where your formal setup always looks like this. It will always be a two-tail what? Test. Okay? Always, always, always a two-tail test. So I'm going to go over the procedure. The procedure is in your notes. And if I recall, I'll look over the what. If I recall, did I show you this in Excel? Because that's my memory. So I'm going to show you guys this open recent. This was that scatter plot that I showed you guys last time. What was the first variable x? What did that measure? Do you guys remember? That was your sleep. So we're going to try to see, is there a relationship between how much sleep you get the night before a test and then your what? Score. I wonder if your sleep influences your test score. What do you guys think? Possibly, right? So when you look at this data, you think there might be, the data might fit in a straight line. And in fact, I think you can insert one. I think if you go back here, we can add, it's called, in Excel, they call that a trend line. And there you go, okay? So hopefully you guys can see that there. And those of you guys are at home, hopefully you guys see that trend line there. That's the whole idea. So we want to see if there's a relationship between sleep and what? Your test score. So you may say, okay, that's great, but I had to rent a TI calculator. So how do we enter a scatter plot in the TI calculator so we know whether to perform a what? A formal hypothesis test. Now, when I have you guys take a look at this here, I want you to remember, first of all, we have to enter the data. We got to enter the data in your calculator. Do you guys remember how to enter data in the TI? You always go to what? Stat, edit, edit. Good, good. Clear that out. And then now, what do you have? Let's go with that data. Okay, I'm going to go with the data from the TI calculator. Or, I'm sorry, from the spreadsheet. So my first list, L1, we enter the X variable information. The first value is 8. Is that true? And then what? 6. And then what? 4. 7, what else? 6, and then 9, 0, 2, 9, and then what? 7. Okay, there's your X values. Let's enter the Y values now. The first Y value is 92, 74, 38, 80, 80, 90, 20, 30, 100, and then 99. Okay, you guys get that there? So I entered all of these values here from Microsoft Excel. I'm going to show you guys. First, you must enter them in stat, edit, edit into 2 lists, 2 columns. All right. Now, this is going to be the graphing portion, okay? So you say, well, how do I start to draw a graph? Let me see if I can scroll in. Because you guys see there's something called stat plot. Look at the gray menu buttons where it says Y equals. On the upper left corner is blue. That's stat plot. So to get to it, you hit second stat plot. And you're on number 1 now, okay? So click enter. And now make sure this is on. And it is on. And then make sure you're on the first graph. Now that first graph in black is a scatter plot. To the right is a frequency polygon. And to the right, there's a histogram. There's a box plot with outliers. This is a box plot with outliers. This is another graph. It's a graph that tells you whether a distribution is normal or not. But, okay. Stick with the first one because that is your scatter plot. Okay? Now, make sure X is on L1 because that's where all the X values are. And make sure Y is in L2. And what I like to do is I like to put my marks as dots. The first one is an open circle. The second one is a plus. That one's a dot. And we are good to go now. You say, what do we have to do now? Well, you know you're looking at that small graph of the scatter plot. I want you to go up here to the zoom key. So you're going to zoom into the graph, and you have to go down to zoom stat. Zoom stat and hit enter. And sure enough, what you guys should see is the scatter plot, and your data is in a straight line pattern, kind of. It is similar to what you see with Microsoft Excel. So here's Microsoft Excel. Here's the TI's version. Microsoft Excel, TI's version. And ladies and gentlemen, it looks like the data can fit in a straight line what? Pattern, okay? You guys okay with that? So now that you know that, you want to proceed to the formal what? Hypothesis testing. Right in here. Now, in order to have a hypothesis test, we need a level of significance. So in this example, I'm going to say use the 5% level of what? Significance. Alpha will be what? 5%. We're also going to use the what? The p-value. We want to show that p is less than alpha. So we're going to do the modern method, okay? So this is very similar to what you guys have been doing, which is what you're going to have do. It's a very similar process. We're going to do the modern method, ladies and gentlemen. So now you say, how do I start to do that? Well, you're going to go to stat, test, like you've been doing. I'll write it here. Stat test. Stat, let's go to the TI. Go to test. And now what you're going to go find in this menu, very simply, is linear regression t-test. Linear regression what? T-test. Let's find it. Let's scroll down. You're going to go all the way down. It's the second to the last. Thank you. You were right. You are right. Linear regression t-test. It's second to the last. Oh, okay. It's F in my linear regression t-test. You guys see it? Hit enter. And yes, make sure X is on L1 because that's where all the X values are. Make sure Y is in L2. Make sure this is on a not equal. And then make sure you hit calculate. And ladies and gentlemen, what do you guys see? What's this p-value? Your p-value is approximately what? Oh, look at this. Could you guys tell me something about that p-value? What do you guys know about that p-value? Isn't that in, what notation is that? Isn't that scientific notation? So what does that mean about your p-value? Your p-value is approximately what? 0. Okay, you guys see that? 2.8 e to the minus 5. Doesn't that make it close to 0? Should we go back at the calculator? You say, I don't know what that is. Well, let's put the number down. It's what? 2.28. Move that decimal how? 1, 2, 3, 4, what? 5. 0, 0, 0, 0. So that when you approximate to the thousandths, okay, you're going where? 1, 2, 3 decimal points. Look at the digit to the right. So this is why we say what? This p-value is approximately 0. Is that smaller than alpha? Is that smaller than alpha? What's alpha? 5%. What do you guys know? What does this mean by the modern method? What is this? Your p-value is what? Is it low? That's the probability the null hypothesis is valid. That's close to 0. That means it's not likely to be valid. So the null has to what? Go. Haven't we been saying that? If the p-value is low, The null has to go. So you go back to the null and you say goodbye, null. Your null's gone. If the null is gone, what do you guys have to do with the alternate? You accept the alternate. What's the conclusion? You have a linear what? Correlation. There's a linear correlation, ladies and gentlemen, because the p-value is what? Low, the null has to go. And that is the end of your hypothesis test. What that says, ladies and gentlemen, is simply that you have a linear what? Correlation between the two variables. So if I go back here in Microsoft Excel, yes, formally we can conclude that your data can fit along that line. All right, you guys okay with that? Now, I'm going to say more here, okay? I know we went through the requirements, and here's kind of the picture. You see this line now? You know what this line is called, by the way? Anybody happen to know anything about this topic? You ever see it before? What's this line called? It's known as your regression line. Or, quote unquote, the what? The best fit what? Line. This is your regression line. It's the best fit line. And ultimately, this is what we're looking for. And from algebra, we have an equation for that. Y equals mx plus b. But in statistics, or I should say, the TI tells you what that line is. The TI says it's y equals, it writes it as a plus bx in the calculator, where you're looking for an a value and you're looking for a b value. Your x variable is stays as x. And maybe we color those differently. A and then what? B. So, ladies and gentlemen, you know, go down here now. What is your A value? Go to the nearest thousands. Isn't that 15.0, what is that? 98? What's the B value? Do you guys see it? Go into the thousands. 9 point what? 518. And then don't forget to put the X variable. Now, this is the format in the calculator here. However, I write it, ladies and gentlemen, like this was in algebra, where you put the X term first. And you got to write this with the right colors here so you guys can see it. So the whole idea is for you to come up with this what? Regression line, the best fit line. This is the whole idea. This is what you want. Okay? That's why you go through the whole process, is so that you can get the regression line. Now, let me say this to you guys. Why do you guys think this is what we're looking for? Why get the regression line? Why is the regression line so important in statistics? Do you guys know? Here's the word. So that you can be what? Predictive. You want to be predictive. What does it mean to be predictive? To have the ability to do what? To predict. So go back. What is your independent variable x? What does it represent? That represents the amount of hours you sleep. Is that true? What does y represent? Your test score. So notice the number 5 is not on this what? This list for x. So I'm going to make this up. This part is made up. I'm going to say to you guys, I'm going to make it up. I want to say, what if you sleep if x is 5? What do? Plug in a 5 for x. Is that right? What do you get for y? You get what? 9.518 times 5 plus 15.0 what? 98. Okay? What kind of test score are you going to get? Go to the nearest whole number. What this is saying is that if you sleep for 5 hours, you're going to get 63% on the test. Okay? What color was, I guess we didn't color the data. So if you sleep for 5 hours here, what's your test score? 63%. That is why you care about the regression line, ladies and gentlemen, so that you can be predictive and now have an equation that tells people the future. Sleeping for 5 hours gives you a 63% on the test. What if you say, no, Mr. Judge, I'm going to sleep for 8 hours? Okay. Sleep for 8 hours then. What do you think you'll get on your test? Well, use the regression line. What that means is 9.518. Now you're going to multiply it by what? How many hours of sleep? By 8. And then you're going to add 15.098. Now, what do you get? What's your test score? 91 what? Percent. So sleeping for 8 hours gives you what? 91 what? Percent. Easy peasy, lemon what? Squeezy. All right? You can be predictive by just putting in some what hours. All right. What do you guys think? Is that okay? Now, you might say, this is a long process, Mr. Judge. And I say, I know. Well, not really. It's just you have to get used to the process. You have to do more than one example. I have a lot of notes here. And just say, by the way here, let me give you some informal information. You know, back in the day, students would have to compute the sample linear correlation coefficient using this formula here. So the good news is ladies and gentlemen, R here, you don't have to, we would compute R, and R really measures what's called the strength of the linear correlation relationship. It's the strength. That's an R value. It's between -1 and 1. And yes, R in the calculator is also listed here. If I go back to stat, test, linear regression, t-test. And I go through the process because it's already there. Hit calculate and scroll down. What is R to the thousands here? Do you guys see this here? It's 0.95 what? 2. So just to be complete with you guys, 0.952. This tells you the strength of the correlation. First of all, R is what? Positive, ladies and gentlemen. So when R is close to 1, yeah, you're going to have a what? R has to be close to 1, like in this case. Here's what we say. R is close to 1. R is approximately 1, okay? Notice this. This is like 95%. So you might say, what does this mean? Well, R is positive, so we say we have a positive linear correlation. Number 1, the correlation was positive. It means that line here is an uphill slope line, positive slope. That's really what they're referring to. But being close to 1, we have to know, is that data, if we look at the picture in Excel, does that data really fit on that line snugly, right? The answer is not. It does. It's not a perfect correlation. So we might even say it's kind of maybe a weak positive. So it looks a little weak. So it's a positive, weak linear correlation. There's a linear correlation, but it's not very strong, but that's okay. We know there's a linear correlation. And so when R is close to 1, if it's very close to 1, it's going to increase the strength of the linear correlation. So that's why they say R measures the what? Your strength of your linear correlation, how strong that is. And that's in your calculator. But back in the day, you had to do all this arithmetic. Yes, now you get to use the what? Yes, okay, TI. Now you guys get it. Now you get it. Nice. All right, you see in my notes? My notes has the traditional method. Everything that I just went through here is the formal test in my notes. This was a test statistic. It's a two-tailed test, always. Yeah, this is a traditional method, but we're going to do this again, but we're going to use the modern method, okay? So I'm going to demonstrate to you guys this whole process again using the what? The modern method. And yes, it's different than the notes, because in the notes I did the what? Well, here's a scatter plot in Excel. Here's your modern method two-tailed test with critical values. And then you had to get a test statistic, not really, and then form your conclusion. So let me go with this again with you guys, but this time we're going to use the what? The modern method. So, you guys ready? What does this example say? Car weight versus fuel what? Consumption. Do you guys know anything about this? Do you guys happen to know that the weight of the car that you drive or you get in, I should say, is a factor in the fuel consumption in MPG, where X is the weight of the car. So this first car weighs how many pounds? 3,175 pounds. What's the fuel consumption? And then that fuel consumption is in what? MPG. And that's what we're writing down here, okay? That the weight of your car X is in pounds. And what's the fuel consumption in MPG? Okay? So this is weight versus what? MPG. We want to know, does the weight of the car impact the fuel consumption? Is there a correlation, a linear relationship between the weight of your car and fuel consumption? What do you guys think? Could there be? Let's take a look. Let's enter this as a what? What's your first step? Scatter plot. Okay, so enter the data. You go to stat, edit what? Edit, clear, L2, and then go up and clear what? L1. What's your first data value? Do you guys know? What is it? I'm going to scroll out because maybe you want to see me put numbers in. Okay. What is it? 3175, and then 3450, and then 3225, and then 3985, and then 2440, and then 25 what? 100, and then 22 what? 90. Okay, go over now, not down, go up. Second list. Do the second list now. 27, and then what? 29, and then what? 27, and then what? 24, and then 37, and then 34, and then 37. You guys okay with this? This is bivariate what? Data. We entered those values, okay? That's what you guys want to do. How do you create the scatter plot? Do you guys remember? You got to go to that stat plot in the upper left. Go to where that y equals, but you have to hit second y. That's in the stat plot mode. Make sure you hit that first one, 1. You always have to have that on. Is it on the stat plot picture? Say yes. That's the first picture is your stat plot. Is the x variable now 1? Yes. Is the y variable now 2? Yes. Do you want it marked as a solid dot? Yes, I do. Now what do you guys get to do now with this? Scroll in by zoom and then go to 9. What is that called? Zoom stat. Now, ladies and gentlemen, what do you see there? Does that look like your data can fit in a straight line? Does it? What do you think? I think so. The line might have a negative slope. Is that right? It looks good to me. I think the data might fit on that line there. So you know what I'm going to do? I'm going to proceed formally with my hypothesis test. And you say, how do we do that? Here's how you do it. You do what? Set it up. H0, H1. It'll always be the two-tailed test. You start by saying, does rho equal 0? Rho is not 0. The top says there's no linear correlation. The bottom is the claim. You're going to claim that there is a what? Linear correlation. What is alpha? 5%, which is 0.5. This is a two-tail what? Test. However, you're going to use the what? The modern method. What's the modern method to this? Do you guys know? You got to get the p-value. Remember that? The p-value has to be smaller than alpha. So you're going to test this formally if there's a linear correlation. Okay, anybody have any questions at this point? How do you test this? You go to what? Stat, test. What do you go down to? What do you go down to? Linear regression what? T-test. Is the x variable now 1? Yes. Y now 2? Is this not equal? Yes. Hit what? Calculate. Now, what's the p-value, ladies and gentlemen? We're using the modern method. What's your p-value going to be? Anybody know? It's going to be 0.00 what? 1. Is that p-value smaller than alpha? What do you think? Yay or nay? Okay, isn't the p-value smaller than alpha? What does it mean? If the p-value is low, what do we say? If the p-value is low, what do we say, you guys? The null has to what? Go. So goodbye, null. You got to go, null. And if the null is gone, what does that mean about the alternate? You accept the alternate, and the alternate happens to be what phrase? That there is a linear correlation. Okay, that's your conclusion. You have a linear correlation here. Okay? Once you know you have a linear correlation, what do you guys want to get? I'll write it this way. This bx plus a. What is this called again? You get your regression line. What is b? To the nearest thousands. Do you guys know? Negative point what? 0, 0 what? 8? What's a? 54 point what? 695. This is called the what? The regression line. Yeah, it's an A because can you see this in the calculator? Could you guys see that under linear regression t-test? What that should remind you, but they don't write it. They write it like these programmers did that. So under there you say y is a plus bx. That's the same as y is bx plus a, by the way. So I write it in the algebra form, and these programmers, that's how they wrote it, a plus bx, okay? So I just write it like you would have an equation. Now again, you say, why do you care about the regression line? Why do you care about that? So you can be what? Predictive. What does predictive mean? Do you guys know? What does it mean to be predictive? Yes. What's the variables? You guys want to tell me? You design a car, and let's say the car weighs how much? 3,500 pounds. Yeah, isn't that a heavy car? Yes, it is. So if you said, "Man, that's a heavy car." You design a car that weighs, that's your X value. 3,500. So you go, if I plug in 3,500 here, let's see what the MPG is. That's the corresponding Y value, okay? Huh? Maybe it's a truck or something. You guys know what I mean?
I just said the average Humvee vehicle.
Yeah, I don't know.
One of those semi trucks.
Yeah.
Yeah. Some of those big trucks, right? They got some really big trucks out there. Negative 0.008 times 3,500 plus 54 point what? 695. What does that equal? You're going to get what? 27 what? If I go to the nearest whole number, that means you'd get about 27 mpg. This is why you care, to be predictive. So if you, ladies and gentlemen, you designed a car that was really heavy, then your mpg is pretty what? Low. What if you designed a car and let's say it's 2,000 pound car? Because it's lighter and there's a linear correlation, we can predict the mpg. So let's say that. Let's see. Just plug that value in now. You say negative 0.008 times 2,000, okay, plus 54 point what? 695. What do you guys end up with? That's about 30 what? 39 mpg. Is that easy peasy lemon squeezy? You guys see the point? The lighter the car, what's the deal? The better the miles per gallon. And so this is what you want to do. You want to get that regression line so you can be what? Predictive. So in this next example, we actually plugged in for right here for X, 2,000 pounds. That's the whole process. This is why you care about this process. So, that's like another example. What do you guys think? Is that pretty simple? If you actually have been doing the linear, I should say the hypothesis testing homework by the modern method, you guys should be really, really thrilled. You think? Okay, let's try this again. Should we try another one? Okay, all righty. See, I even put the procedures here on the what? On the notes. So these notes, if you guys print them out for yourselves, I got your procedures here. This is what you guys do. This is a car example. And then let me remark about this too. Here's your procedure for how to do a scatter plot. It's in the notes, ladies and gentlemen. You could download them for yourself. There's your scatter plot, okay? You go, okay, we're trying to look for a regression line. What do you guys notice about this, by the way? This line has a what? It's a negative slope. So this is going to be a negative linear correlation. Negative. Let's see how strong that was. It's the R value. So in your calculator, here's the R value, okay? R is about a negative what? 943. So this is close to, R is close to -1, which is why we say there's a negative linear correlation. And this, again, is probably going to be a pretty what? Right? A negative. It's going to be a weak linear correlation. This is called a weak negative. Strong positive. There's either going to be two words, weak or strong. Weak or strong. And we'll see a strong linear correlation and a weak. But this is in the notes. This is in the notes, ladies and gentlemen. I put that all in the notes for you guys. So, contact Elon Musk. Maybe he wants to buy him. I even put all the summary. This is what you guys have here. Summary is there.
Elon Musk.
Think he'll buy him?
Probably.
I hope he bought Twitter. He could buy these notes. Then I could go to Hawaii and just relax. Have pineapples and what? Coconut, pineapple, what else?
He'll probably use them in his next project.
Yeah, I could use them. What's the deal? What else can you have at the luau? What do you guys eat at the luau? No pineapple.
If there's pizza oven.
Do you have a pizza oven? So you even got the regression line. Show you guys how to get the regression line. It's in the notes. Let's do it. Let's do this. Let me actually do a random example for you guys. Let me do this. Let's go here. Like if I said to you, I'm going to randomly put some data. So I'm going to do something like this. Stat, edit, edit. Let's put some random data here. I'm going to see what happens if you randomly put some data values, because this can happen. If I said to you guys, 5, enter, 4, enter, 8, enter. Let's pretend this is sleep time again. 6, enter, 9, enter, 5, enter, 4, enter. And sleep time versus the grade here. So I'm going to put some kind of random percents here for you guys here. Okay, 95%, 57, and then we'll say 78. All right, 10, okay. 10, okay. And then maybe 2, or not 2, we'll do 22. All right. Let's see if we have, is that enough data? Let's see. Okay. So, scatter plot time. Second stat plot, 1. There we go. Everything's the way we want it to be. So all we got to do, remember, it's on the first one, scatter plot. X is L1, Y is L2. Zoom, go down to zoom stat. What do you guys think? Could you fit all that data on a straight line, you think? What do you guys think? Yay or nay? No. And if I said to you, using like the 5% level of significance now, right?
Looks so messed up.
Yeah. It's really like a random, data's not in a line, right? So I'm going to say to you guys, we're going to use 5% level of significance. So by the modern method, if we said stat now, test, linear regression what? T-test. Okay, everything is where it should be, right? X is an L1, Y is an L2, two-tail test, always a two-tail test. What do you guys notice about that p-value? What is p approximately? 0. What? 5, 6, what? 6? What do we just see? 0.566 is not smaller than what? Than that 5%. So if it's not smaller than 5%, we got to keep the what? You got to keep the null. Is that true? So remember, in this case, keeping the null, since our formal hypothesis test is done always in the same way, what does it mean to keep the null? That there is what? No linear correlation. So when you look back at that list, this is a picture. If I go back to the, again, second stat, enter, zoom, number 9, zoom stat, You can now say, ah, yes, that is what's the story there. Scatter plot. There's no linear correlation. That's an example of no linear correlation. Look at the R value in the calculator now. R is going to be close to 0. Because that's what that meant. Rho is close to 0. R is close to 0. Stat, test. Stat, test, linear regression, t-test. Let's see what R is. What do you guys notice? R is about what? Negative what? What's R? That's not really, that's closer to 0 than it is negative 1, right? Negative 0.26 what? 5. So if it's close to 0, no linear correlation, whether it's positive or negative. So that's a lot closer to 0. So you can't even talk about the strength of a correlation because there is no correlation. No strength because there's no linear correlation. You guys see what I mean? R close to 1, positive, strong positive. R close to negative 1, strong negative. Okay. Let's look at another example. This is another example where I say to you guys, what does this represent? I think, again, this is a random set of data values, X and Y. And what I wanted to show people here in this scatter plot here is, doesn't it look like that data fits pretty well in a line? That looks really good, don't you think? And it's a positive slope for a line. This is really going to be a picture of a strong what? Positive linear correlation. See? It looks like a strong positive. You say, why is it strong? Because it looks like it is on a line exactly. Strong. Why is it positive? The line has a positive slope. Now, what do you think will happen if we enter that data? If we enter that data, the bivariate data in our calculator, I won't do that because you have your instructions here. And there's a line, and ladies and gentlemen, let's do the modern method. You're going to see the modern method. What's your p-value? See the p-value over here by the modern method? What's that p-value? Anybody want to tell me? Isn't that scientific notation where the digit goes 7 spaces to the left? So what do you think that means about the p-value? Where is it? I want to put my summary. Here's my p-value. P is approximately 0. Using the 5% level of significance, is that p-value low? Is p smaller than what? Alpha. Is that p smaller than alpha?
Yes.
What does that mean? If the p-value is low, the null has to what?
No, has to go.
Go. If the p-value is low, the null has to go. So when you say goodbye null, what does that mean? You have a what? Linear correlation. When the p-value is low, the null has to go. There is a linear correlation. Look at R. Is that R close to 1?
Yes.
It's really close. Is that right? I mean, that's the best we've seen so far. That's 0.993 to the thousands for your R value. That's really close to 1. So this is why we say, as a conclusion here, that this is a picture of what we call a what? Strong positive linear correlation. R is very close to 1, by the way. That's the strength of it. That's like 99% of 1, because it's a decimal. 99% of 100%. So that looks really good. Like, that looks almost perfect. Is that true? And of course, you know, when you make this conclusion, at the end of the day, what do you really want? You want the what? What does that give you here? You want the regression line, don't you? Where this B value is there, and then you have the what? The A value here, okay? It's a regression line. So get that B and A value here for the regression line, and that's why you cared, so that you can be what? What's the word? Predictive. Easy peasy lemon squeezy. Yeah, it's really good. What do you guys think? Isn't that fascinating? Now, I'm going to have you guys try this out yourself in your TI. You're going to use here, this is going to be the 5% level of significance, where the X variable here is going to measure your study time, how many hours you study. The Y variable is going to measure what? The grade in percent. So your X value, study times. The Y value is the what? Grade. So I'll give you guys some time. Go through the process, okay? Create a scatter plot. Check to see if that looks good, like there's a linear correlation, your data's in the form of a line, and then proceed with your hypothesis test. You guys ready to try this out? You guys ready? Hey. Mu and sigma, go over there. Let's try this out. You guys ready for this? We're going to enter the data. Stat, edit, what? Edit. Okay, clear this out in L2. Clear this out in L1. Here we go. First data value, 20. Enter. 40, what? Enter. 50, enter. 60, enter. 80, enter. 100, enter. The second list now will be what? 40, enter. 45, enter. 70, enter. 76, enter. 92, enter. 95, enter. Okay, you guys okay with that? So we enter the data now. So how do we create the scatter plot? Second y equals stat plot. Go to number 1. Make sure it's on and it's the first one. That's the scatter plot. L1 and L2 looks good. The X list is L1, the Y list is L2. Good. Now go to what? Zoom. Number 9, zoom stat. What do you think? Does that data look like it can fit on the line? What do you guys think? Does that look good? Looks good to me. It looks like the data might fit on the line. If it does, it could be weak, but it still fits on the line, right? All right. Now, how do we really know again? What do? Stat. Test, ladies and gentlemen. But before you do that, you're going to have to set this up. Remember this? H naught, rho equals 0, no linear correlation. H1, linear correlation, that is the claim. You're going to use the 5% level of significance. Your p-value needs to be less than alpha. Alpha is 5%. So we're going to use that modern method. Because they said alpha is 5%. Okay. Stat test, we go down to what? Linear regression, what? T-test. There you go, F. Yes, the X variables are now 1, Y is now 2, not equal. Let's calculate. What do you guys get? What's that p-value, ladies and gentlemen? P is 0.00 what? 4. Is that going to be less than alpha? What do you think, ladies and gentlemen? Is the p-value, which is 0.004 here, is that less than alpha? Is it? Say yes. What does that mean? It means the null what? Has to what? Go. So if the p-value is low, the null has to go. P-value is low, the null has to go. So you go, okay, null. What do you say? Goodbye to the null, which means hello to the alternate. And the alternate hypothesis is the claim that There is a linear correlation. And so now we're free to do what? To get the linear regression line. Okay? So we're free. This is the traditional method. And we're going to get the regression line. So, I mean, you could fill in all these values, but let's get that regression line now. The regression line in the TI again is y equals bx plus a, right? And I know the calculator says a plus bx, but we can switch the order in which we add because the order doesn't matter. So what's b to the nearest thousandths? 0.768x. And what's a?
24.857.
Ladies and gentlemen, you are what? Done. Okay, so you have the what? You have your regression line here. The regression line. All right. Easy peasy lemon what? Squeezy. Let's see how strong that was. What's the R value, right? R value. That's 0.950. That's like 95%. So R here, if I even go up, 0.950. So we can say that this is going to be, remember, it's a positive slope. I would say that that's a weak what? Positive linear correlation. No, there's still a linear correlation, but it's weak. It's not close. It's not really close to 1. It's like 95% of 1. If I were to go back and look at the data values and it's not there, you guys can say, yeah, it didn't look very strong. It looked kind of a little weak, but, you know, we have to have a choice. We say weak or strong, weak or strong. Did you guys get that one? All right. Let's do this one here. This is computer sales, okay? They're going to say here in this question, use the what? The 1% level of significance, where X, if you guys didn't know, you guys get a lot of telemarketers calling you. You know why? Because they make money in sales. So the number of calls they make, there's a linear correlation between the calls and the sales that they make in thousands of dollars. That's in K. Okay? Number of calls per week versus the sales they get in thousands of dollars. I'm going to give you guys time again. I'm going to have you guys try this one again because practice makes what? Practice makes perfect. Try this yourself, okay? See what you get. this, right? We're going to try this out. We're going to enter this as a scatter plot. This is the sales and the number of calls. So, ladies and gentlemen, let's go to the TI. All right. We go to Stat, Edit, Edit. Clear out your Y variable. Go up here and clear out the X variable. Okay. We're going to enter the data. Is that right? We're going to enter these values here. Okay. $10. What else? $15. $12. $20. $25. $17. Those are all the X values. Let's get the Y values, okay? Oops. Clear that out. Okay, Y values. 37. What else? 43. 37. 49. 54. And then what? 45. See if I can find this. All right. Let's take a look. Second Y. Enter. Looks like everything is good. Is that right? If you've been doing this over and over again, it's going to stay in the same settings. Just so you guys know, it'll stay in the exact same settings. So now you just go to what? Zoom stat. And that looks pretty good. What do you guys think? That looks like the data might be pretty strong on a line. Doesn't that look like it kind of lines up? I think that looks like it's going to be a strong linear correlation. Now, let's set everything up now. You say, what do you mean? Well, you have to set this up as H naught rho equals 0, no linear correlation. H naught rho is not 0, there is a linear correlation. We're going to use the modern method, so we need the p-value. We need to show p is less than alpha, or p is smaller than that 0.1%, okay? It's a very sensitive test if it's 1%. Let's proceed with the test. So, you say stat test, go down to what? Linear regression t-test, G. Okay. Oops. Linear regression t-test? No. Stat test linear regression t-test. It's the test. L1, L2, two-tailed test. Yes. Hit what? Calculate. What's your p-value? Do you guys know? If I write this down, isn't this 1 point what? (1.5) times 10 to the minus what? 4. Move that decimal how many spaces? 1, 2, 3, what else? 4. Okay. So when we approximate tenths, 100,000, so the digit to the right, so ladies and gentlemen, your p-value is going to be what? 0, 0, 0. So 0 is definitely smaller than the 1%. So yes, your p-value right in here, smaller than what? Alpha. If the p-value is low, you say the what? The null has to what? Go. So goodbye null. What does that mean? It means you have what? You have a linear correlation. We're going to use the modern method. All right. So not the traditional method, modern method. Now, we need the best fit line. So we're going to have to go back to the TI for that best fit line. Is that true? Notice in the TI, y is a plus bx. So we need the b value to the thousandths. That's going to be 1.214. Is that true? Do you guys see that for b? 1.214. And then what's a? 24 point what? Is that 135? Double check. The best fit line. This is also called the what? Your regression line. Why do you need that? So you can be what? Predictive. What's the R value? Let's see how strong this is. How strong is this? R is, well, it looks like it's almost 99%, right? R, what's the R value? If I go to the thousandths, isn't that 0.990 to the thousandths? Did you guys get that there? So that value is close to what? 1. Okay, so this is why we're going to say there's a what? Strong positive linear what? Correlation. You got a strong positive linear correlation. We already got the p-value being 0.000 here, just so you guys know. So you have everything here by the modern method. That t-value are the test statistics by the traditional method, but we're using the modern method. Easy peasy, lemon squeezy.
See.
All right, now let me announce a few things to you guys here. What do you guys think? You guys get the handle of this?
I think so.
You want to try one more? No? Want to try one more? What do you guys think? Are you good? Are you good to go with this? All right, wow. Here's what I'm going to say to you guys. Let's go back over here. Now, your homework, as you guys can see, is linear correlation and regression. On my website, what do you guys think I have for your homework? Right, here's your homework. Do I have solutions for you guys there? Yes. Oh my God, I went through all the I did both traditional and modern methods so you guys can see. So I did both for you guys. There's solutions. Oh, you guys can't see it. Sorry. Let's go back so you guys can see. So what I'm saying to people here is your homework is going to be, it's in Canvas. It's this linear correlation and regression worksheet is your homework. And then I have for you guys here the solutions for them. Okay, I have both traditional and modern method, p-value method. If you want to see more examples, you got a nice video here.
The 1 billion question.
You guys know what I mean? You got this video. Just so you guys know. Now, here's what I'm also going to announce to you guys. What did I give you guys as an announcement? Did you guys get my announcement? No? Well, I sent it. Let's see.
What you sent? This
Did- What is it? Okay, let's ask you guys this question. You guys see? What the hell?